Welcome to Kenton's videos. Enjoy the video.
Start by selecting a motor specified for high RPM operation at 12V. Choose a motor rated for 10,000 RPM or more to ensure headroom. Design blades at 5 inches diameter with a 20-degree pitch for aerodynamic efficiency. Balance is critical. Allow 1 gram tolerance across blades. Specify shielded angular contact or deep groove ball bearings for low friction. Plan for 22 AWG enamel magnet wire if rewinding becomes necessary. Prepare a rigid mount to minimize vibration during testing. Begin disassembly and remove any non-essential rotor mass carefully. Lighten the rotor to reduce inertia by about 20% while maintaining balance. If using a brushed motor, consider rewinding the stator with 22 AWG wire for higher RPM capability. For brushless designs, upgrade the controller to one that supplies up to 30 A continuous current at 12V. Replace stock brushes with high-temperature graphite brushes if retained. Always recheck dynamic balance after each modification step to prevent catastrophic failure. Assemble the modified motor with the balance 5-inch blades and secure all fasteners. Apply medium-strength thread locker on rotor fixing bolts to prevent loosening during high RPM runs. Start testing at low voltage increments and measure RPM with a digital tachometer until 12V is reached. Monitor vibration with a meter and keep measured temperature under 80 Celsius using a thermal probe. Perform initial test runs in 5-minute increments up to 30 minutes to verify stability. If vibration rises, stop and rebalance immediately.
Thanks for watching. Consider subscribing if we helped you.